generally use words like moderate in traditional courses in this class, statistics, probability statistics, because there is kind of an in-between.
Of in between of what?
Well, you wouldn't want to say like he's the best baseball player and he's the worst baseball player. You'd say, well, he's good, he's very good.
Okay.
You know, like it almost sounds like a slight to say, well, he's weak, or this is weak. But what you're really saying is it's not strong.
Got it.
It's not strong. It's weak. It's based on the words that they give you.
I see.
So then the one on the left here, this number 2, this is also strong. So it can be strong in the positive direction, strong in the negative direction.
Got it.
And this one would be weak, meaning weak relative to this. Now, when there's no correlation, there is neither weak nor strong. There's just no correlation.
Got it.
You have to know this to be successful in this part of the course. Just a fact. Okay. Blah, blah, blah. Here we go. All right, use a scatter plot to find trends in data. The table shows the enrollment of students in an SAT prep program over the past several years. Wow, I wish my enrollment looked like this. It's pretty amazing. When making a scatter plot, which quantity would go along the x-axis and which would you graph along the y-axis?
My x-axis would be years, and SAT prep course enrollment would be my y.
So typically time goes on the x-axis, okay? Yeah. But the answer is actually, you can actually go either way. And you'll see this in other courses where they actually switch these. They typically don't do it with time, but when the variables are say something that where one doesn't lead to the next, they could actually go anywhere. But time is typically on your x-axis here.
Got it.
And I think we talked about that too. It's good to kind of order the x values as well to see if there's like a general trend. Like, do you see the enrollment going up or down or neither in this case?
I see it going up.
Yeah, and it doesn't have to go up like every one doesn't have to go up. You just have to see from start to finish a general increase.
Got it.
Like your batting average, I don't know where you're at, but like, maybe game 2 versus game 6, you've seen some improvement. And then, in the case of like batting average or even enrollment, sometimes things level out. Like these trend lines don't go on forever. We'd like them to, but that's something else to consider. So kind of a long answer. You already said it here. So put something down in that regard, and we'll move on to the next one here. And for some reason, okay, I did upload. Do you have this printed out in front of you?
Pardon?
I
have it on my computer.
Okay, because B, you're gonna have to make a graph, and there's
B, we have to make a graph. That's okay. I can do that.
Okay, all right.
Yeah, no problem.
So I'd like you to graph those
Plot
points,
that? Okay.
and then I'll jump in and graph mine after.
All right, I've got it.
Okay, so the graph, if you've done it reasonably accurately, and that's what they've got here, it will show you an increase over time. Okay. Now, if you and I, let's say you and I were running an SAT prep course, and we looked at the data, we could then make some inferences. We could say like, well, what happened between year three and year 4? Like, why didn't enrollment continue to go up? We might wonder, we might go back and look, and who knows, could have been COVID year, could have been a lot of things. If we were projecting into year 7, we might say, well, we're probably going to have, 300 enrollments, and maybe we need to hire another person to help with whatever we're doing, or maybe we need to upgrade the the website or something like that. That's why you plot this data, to get some because the data itself is useless. It's when you do something with the data. That's why I was asking about the analytics in your baseball. Like, unless you're going to track the data and do something with it, doesn't matter. All the data in the world doesn't help you. So we can do kind of like what we've been doing. We can say, okay, there is positive correlation here, and then you have to decide whether it's strong or weak. And if you say strong, which I would hopefully say, you'd want to say something about how it fits very tightly around a line.
I could say positive, or like, what do you mean by tightly? Like it's right there on the line?
It's close to the line. Is the idea. The data points kind of all grouped together is another kind of word you might consider using.
Yeah.
You want to give some explanation for why you believe it's strong. That's the show your work part of this.
Oh, okay. So there's the actual plotting and then the showing your work.
Well, it's like you got to give a line that you think roughly goes through it, and then decide, is it tightly coupled around it or not.
Got it.
Let me know when you're ready to move on to.
I'm ready.
Part C. Okay. All right, scatter plots can help us notice trends in data because they provide a visual representation. Noticing these trends can help us predict data points that are not included in the original set. Based on the trend in the data, what will you say will happen in enrollment in another year? They're kind of referring to that year 7. What do you think will happen in year 7? So you want to say something like, well, in year 7.
In year 7, there will be
enrollment will be, and then you provide that whatever you think it will be.
Let's say 3,350.
Okay, and that's fine. Yeah, whatever it is, that's.
Got it.
Okay. Next problem here looks like a new problem altogether. Trend line, blah, blah, blah. Okay. Since you have to do this, why don't you quickly, I guess you might need some help on that. All right, so let's go to part B. All right, so example 2 here. They're telling you that the home prices tend to be more expensive the closer they are to metropolitan areas. That is not always true. Tucson's a good example of that. Sometimes the more expensive homes are, a little further out.
Yeah.
The table shows the relationship between the average price of a home and its distance from the city. Okay. Now, in full disclosure, if you go out 40 or 50 miles from downtown Tucson, you probably get a pretty cheap home.
Yeah.
But anyway, this is what they're saying here. It says create a scatter plot using the data. We'll get to that. That's in the lower right here. Well, I take that back. I guess we do need to graph because you've got to get some
Yeah, I can graph
idea.
this.
Now notice they don't give you a scale this time though. So you kind of have to decide what scale you're going to use on the X and the Y axis. So notice you go from 0 to about 115. Let me just count these real quick. 1, 2, 3. Okay. So I recommend going by 10 on each of these.
Okay.
And then you kind of scan your values here, like, okay, 500,000 all the way down to that. You might want to go up by either 50,000 would be one option, or go up by 100,000.
I was gonna do 50 because
Okay.
yeah.
And that'll do it for you here. So go ahead and work that out. And
Got it.
okay, do you see? Well, let me say it differently. How would you describe this to someone that could not see the data? Like, what words would you use?
I would say definitely a negative correlation, pretty tight or
Okay.
strong.
Yep, I agree. I think it's going to get to that, but for now, it just says to create a scatter plot. This is one of those things like the test thing. It's all right, check, I've done that. Here's what we've not done though, and I'm very bad at this. We have not labeled, or maybe you have. I definitely did not. Miles from center. Okay, and then home price of home.
Oh, for the X's and Y label.
Yeah, and a graph without axes labels is useless. So you really need to like include this.
Got it. Proof.
All All right. Now we actually need to get to the question here. Choose 2 points and use them to create an equation for a trend line.
Mhm.
So there's a couple of ways to do this. One, sometimes people just choose the like sort of the first and the last, or the biggest and the smallest. You know, there's some advantages to that. You could also choose kind of points that you feel like best fall on the potential line. You know, basically no line, no 2 data points that you pick are going to be ideal here. And let me
Yeah.
try to explain that. So like if because I think maybe you might say, okay, that looks like the right line. You want the same number of points kind of above and below it. But when you start moving this thing around, you're like, well, is that better? Is you know, is that better? You know, it's like hard to say. So but based on what I see, you probably want to use, you know, I'll just say maybe this point and this point. They seem to kind of, but then what's going to happen is this point up here will be a little further away than maybe you want. It's not an exact science. It's not like you know, the problems you've been doing in the past where they just say use these 2 points. You have to choose here. So I'm going to suggest we use the this point and this point, and we'll go back to the table here. So that's the 41 and the 75 here. Okay.
Got it.
And then we have to actually find the equation. So to do that, we're gonna write the equation y equals mx plus b. So we need 2 things. We need the slope. This. So the x1, x2, y1, y2.
Yep.
All right, so go ahead and put those numbers. You definitely need a calculator if you don't have one for this.
I don't have one on me, but I can use the computers.
Yeah, let me send you a link to one that I like. You may find this one works well. I'll drop that in the chat.
Okay, Desmos, sweet.
Nice thing about that calculator essentially is you can enter it exactly the way that it's written.
All right, so I have negative 75,600 over 34, but then this
Okay.
has to reduce.
Yep. Keep going. Yeah, and round to like the ones place.
Wait, what do you mean?
Like if like whatever your number is, no decimal places.
Okay, got it. Okay, I have negative 37,800 over 17.
Okay, so just go to the calculator. You're just putting that number in and rounding it. Like there's not, you're not reducing. You're not like this isn't the normal math. You just give me the final number. It should be around minus 2,200 and something.
Yeah, it's it. Hold on. Okay. Negative 2,223.
Yeah, 24 be a little
24
better,
plus
but
5.
Yeah, but that'd be acceptable. Okay. Now that's just M. Okay. That's that's a start. Got minus 2, 2, 2, 4 x plus b. So you have to use one of those ordered pairs you just found. Let's just use the first one. 359,999 equals minus 2, 2, 2, 4 times 41 plus b. Okay, so you want to use this to solve for b.
What's the okay? So for
So
solving,
I'm using this first XY pair just by choice. There's not really like a reason
okay.
for it, but you want to pick the one that you like and then solve for b here. So you got to multiply the minus 2, 2, 2, 4 and the 41 and then move it to the other side of the equation.
Okay. On the left-hand side, I have 451,183.
Yes, b is like you just said, that value, and then that goes back into the original equation. So now you write your final equation, which is minus 2,224 x plus 451,183.
Got it.
Okay. So I know that was a lot. That's everything for that one here, and then the rest of it should go pretty quickly here. So let's take a look here. Part B. All right. So explain what your slope and y-intercept mean in the context of the scenario. So you're going to get a question on your test, which is to interpret the slope. And there's a kind of a recipe for how to do that. It's very much like these words always are included. And it goes like this for the slope. For every 1 unit increase in x, y, and then you have to choose the word, increases or decreases by y or by slope units. Okay, so it's kind of a fill in the blank here. So for your problem, it's for every 1 mile increase from the city center. So notice I don't say x, I just say what the variable is. The y value, the price of the home, decreases by $2,224. Okay, so the
200. Got it.
So the important thing for you to remember is that this thing you're going to use in every single one of these explain problems, but you don't say x, you don't say y, you don't say unit. You have to choose increase or decrease. But this is the recipe. If you write this, because here's how your instructor's grading it. He's looking for mile, city center, price, decrease, that number, and that. Everything else is irrelevant.
Got it.
Right. The y-intercept now is not as formulaic. You have to interpret like whether it actually means something. what does it mean when X equals 0 in this problem? What is X referring to in this data set?
That'd mean you're right in the city,
Downtown. Okay.
downtown.
So depending on, your life experiences, you might know that that's downtown, but you'd want to say it that way. You would say a home downtown, it has a price of, and then whatever that y-intercept, I think we said 451, 153, 183.
Yeah.
But notice I'm not saying X equals 0. I'm not saying the y-intercept. You're supposed to give it a physical meaning. And sometimes
downtown has a price. Okay.
yes. And sometimes it does not have a physical meaning. And we'll maybe see that in a future problem here, depending on what they throw at us. Let me know when you got something down for that, and we can go to C.
Yeah, I got something down.
So C is a question that you will see in every regression line that you write. They're going to give you an X value, in this case 50, and you have to figure out the Y value. Okay, it says, what is the reasonable home price for an average home that is 50 miles away from the city? How do you know?
300,000.
Did you already put that into the equation?
Oh, no.
Okay.
Put that in.
You have to put that into this equation right here. It's like, wow, that's fast.
Put in 50 for X.
Yes. So you're going to multiply by 50 down here, and you might be right. I mean, it's going to be.
It'll be close to there, but it won't be
right.
exactly that.
Right, and that's where, if you're just having a casual conversation, you're like, yeah, about 300,000, and let me know when you got a value for that, please.
Okay. So I have, wait, no, I don't have the final thing. I just need help for a sec. So I have, 100,000. Well, I have 111,200 negative plus 451,183.
Yes.
So now I would add that and put it to the other side.
No, they're on the same side of the equation. So you just combine the numbers.
So I just combine them.
Okay. Yes.
$339,983. So
Okay.
339,983.
Yes.
Got it.
All right. So the next question, D here, this question says, is the equation you found in part A reasonable for all values of X? There's kind of a bigger question here, which is whether you can do what's called interpolation and extrapolation. And we love in our society to extrapolate. We like to say that, like, these curves are going to go on forever. Like, yeah, that's going to work forever. Or in the case of, like, when we were up here graphing, enrollment, it's like, yeah, it's going to go on forever, right? But that's not true. Things don't always go on forever in the same direction. They might go for a while, but they may not go on forever.
Yeah.
So let me ask you, for a house that is, if a house is 200 miles away, do you think that this would be a reasonable equation? And let me give you the output for that. Give me just a moment here. The Y value ends up being $6,383. Is that like, that's what the equation says. Is that reasonable for a home that's 200 miles away?
No.
Okay, I agree. Now, the kind of the where we go from here is based on how much you understand or know about home pricing. And you don't have to know a ton, but homes typically are more expensive than cars, and you can't even get a used car for this price right now.
Yeah.
I mean, you can, but if you've seen used car prices, I'm not sure how much you're looking at that. You're probably 6 months away from that or more, but
Yeah.
it's like, it's hard to find anything right now. So you sure can't get a house for that much.
Yeah.
So the answer is like, no, it's not reasonable for all values of X. Typically they say this equation is only good for the X values that they give you in the problem. Basically, it's only good from say 12 to 115 miles.
Got it.
But I'm not sure what they're looking for here exactly, meaning that like you got to check with your instructor on this, because he's grading you and his information is gonna be more valuable than mine
Yeah.
at this point.
Got it.
All right, page
144.
Yeah. And you said only certain ones on this one, or?
Yeah, let me double check. Pages 144, 1 and 2.
Okay. So we'll start with number 1 here. Hopefully these are a little more in sync.
Yeah. It should be.
What we've been doing, looks like they are. All right. Isaac made the scatter plot, right, to show how his weight changed as he got older. Do you agree or disagree with the way that he set up this scatter plot in order to represent the data? We did talk about that earlier. Time is up here. Is that the best way to do it?
I mean, I would have it the other way. Where
Yes.
weight in pounds are on the Y.
Yeah. So you want to say that time on the X-axis, weight
Other than that, it looks good.
on the Y.
Got it.
All right. So this is where question like B, you got to really pay attention. It says would the equation, it doesn't say to calculate the equation, it just says would the equation weight give a reasonable value for his weight at the age of 40. Basically, they're like, imagine this continued on forever. And actually a little,
Yeah, it would continue until he's 40.
Okay.
I don't know at the consistent rate.
Well, what number would be the weight roughly over here? Like, give me kind of an estimate of where you think that would be.
Like 300 pounds, but yeah, it looks like that's a little, or it could even be a little more. No, like 300.
Yeah, I'm probably not gonna, let's just call it 400.
Yeah,
just
400.
because I mean, I hate saying it, but 300 actually isn't unreasonable in our world right now. So we can laugh, make jokes and all that, but like this, unless you like know someone this big, like this is actually really weird. It's like knowing someone that's like 7 feet tall. It's really odd. And while people are overweight in this country, and it's a problem and all that stuff, this is not that class, but it's like the question is like, does your weight actually keep going up and up and up and up and up? Well, it can if you eat like crap and you don't work out and you watch other things, but is that what most people happen? Or your dad, I'm assuming is this age or bigger. If you've seen pictures of him from when he's younger, he probably looks much the same. I mean, he might be a little bit different, but and there's kind of like a side conversation to be had here, which a lot of people, once they hit this age, they kind of maintain what they are. Some people let themselves go, but you kind of got to figure out what you are by this age. Are you going to be a fitness, or are you going to let yourself go? And when you're young, you think, ah, no big deal, but it's a lot harder when you get older. You gotta keep doing the weight workouts, keep up in your cardio, stretching, and all that stuff. So
Yeah.
no, the equation is not reasonable. And you want to say that like he's not going to consistently gain weight on average over his lifetime, something like that.
Got it.
All right. Question 2 here, 2A. We'll get to B. B is kind of based on A here. So it says, consider the scatter plot relating the year to the tons of recycling in that year. So we start here in 1990, 2010-ish. You can see that the tons of recycling has gone up. That's a good thing. If maybe that means we weren't recycling enough and now more people are recycling, that's good. So it says, use algebra to find an equation of the line of best fit on the scatter plot. The last time we did this, I sort of said, just pick kind of the points. When you have a line though, you don't do that. You look for nice points. Like this is a nice point and this is a nice point on the line. Okay. The first one is 1990, comma 40. And the second one is 2010, comma 90.
Those are perfect.
Yes. And that's what you're looking for. Now, there's a small little thing here that you'll probably address in class. Typically, you don't use the year. You use the like years from 1990. But in this case, since we don't know any better, we'll actually just use the year.
Okay, so it'd be 90 minus 40.
Yes.
2010 minus 1990.
Yes, that's your slope.
$50 over 20. So 5 over 2.
So that's only part of it though. That's checkbox 1. We've got y equals 2.5x plus b. To find the b value, you have to use one point or the other. It doesn't matter which. You pick the one you like better. Which one are you going to pick?
Let's pick 1990, 40.
Okay, so 40 equals 2.5 times 1990 plus b.
$40 equals 4,975 plus b.
Okay, so subtract that over.
Subtract 4,000. Negative 4,935 equals b.
Good, and that goes back into your equation. So y equals 2.5x minus 4,935.
Nice.
Okay, we got enough time to answer question B. Question B says to use your equation to determine how much waste is expected to be recycled in 2015. That is your X value. X is 2015. So you're going to write your equation with 2015 in it. And you'll get a result there. You should get 102.5 pounds.
Yeah,
sorry, millions of tons. Pounds,
yeah.
millions of tons. All right. So I think that's a good place to stop. I don't think we can actually start another question here. Pretty close to the end. Let me just double check. Yeah, pretty
Yeah,
much.
we got all the homework done.
Oh, good. That's great to hear.